Ladies and gentlemen, on behalf of Swansea University, College of Engineering and Zienkiewicz Center, may I welcome you all to this annual Zienkiewicz lecture. I especially welcome our alumni, guests, and students. My name is Perumal Nithiyarasu. I am the Director of Research at the College of Engineering in Swansea University. I also chair the advisory committee for the Zienkiewicz lecture. Today's lecture was possible due to excellent support we received from the University, College of Engineering, Zienkiewicz Advisory Committee, supporting organizations, and Professor Zienkiewicz's family, who are also here. Professors Roger Owen, Professor Roland Lewis, and Professor Ken Morgan, and many others. Professor Owen, who is a research professor at the Zienkiewicz Center, has kindly agreed to chair today's lecture this evening. I now invite Professor Owen to introduce the guest speaker. Professor Owen.
Thank you very much for that introduction. I know we're short of time tonight, so I think I'll try to keep things as short as possible. First of all, I'd like to briefly summarize Oleg Zienkiewicz's career. I'm sure most of you will need no introduction. And then after that, of course, I will like to introduce Professor Bhattacharya, who again, we are privileged that he's agreed to give this lecture. And again, it probably doesn't need any introduction, but I'm going to give one in any case. Okay, so let's start with Oleg. He was born in England in 1921, as it says there. But the important thing was he was the 7th son of a 7th son, which according to clairvoyancy, that he had magical and mystical powers. And that may be responsible or may not be responsible for his remarkable career. His father, Casimir, worked in Birmingham. He was a consul for the Kerensky government. But this was short-lived because it was quickly overthrown by the Bolsheviks, and the Zienkiewicz family returned to Poland, where he took up a post of district judge in Katowice. But of course, fate intervened in the form of the Second World War, and after some turbulent times in Warsaw, the Zienkiewicz family managed to get a visa to Italy, which had not yet entered the war, and then moved on to Angers in France, where Casimir Zienkiewicz worked for the Polish government in exile. But of course, this didn't last long with the invasion of France by Germany, and the Zienkiewicz family moved onwards to the west coast of France, to Bayonne, and they eventually boarded a boat for Britain for the UK on the 22nd of June, which is the very last day. It is the day that the armistice between Germany and France was signed. As soon as he is in London, Oleg went to study at Imperial College. The British Council had some awards available for Poles to study there, and he decided to take up a degree in civil engineering. And he graduated in 1943 with the first class honours, of course. And then he decided to do a PhD, and he approached Alfred Pippard and Sir Richard Southwell, and they had a joint project on the analysis of a dam. Oleg finished his PhD in 1945, after which he went into engineering practice, and then finally, 4 years later, got a job as a lecturer at Edinburgh University, where he met Helen Fleming, who was a graduate student in chemistry. And they married in 1952, and his son Andrew and David were born in 1953 and 54, respectively. In 1956, they moved on to Northwestern University in the States, where daughter Krisha was born in 1958. And then we finally come to the thing that he's most famous for. He arrived in Swansea in 1961. He was a successor to Professor Bernard Neal, who moved on into Imperial College, And Oleg relished the position of taking up a professorship in the UK system at that time, where you could influence the career of many other people. Also, it is an unprecedented expansion of British universities at that time. I have no time to talk about his work, but I'll just mention that he worked in many different fields. And of course, the thing that held everything in common there was the fact is the numerical methods. And the three little items I'll show that one was the Clywedog Dam in 1963. This was the first time finite element method had ever been used in commercial practice. And as you can see on the bottom there, that the mesh used is very coarse, because that's due to the computational power of that time. And secondly, in 1965, Zienkiewicz recognized that finite element method could be used for problems other than for structural analysis. He recognized that you didn't need to have a potential function in order to solve problems, and he managed to actually recognize that the fact that if you had a differential equation with boundary conditions, that you could solve problems by using weighted residual methods. And this led the way open to solving problems such as thermal problems, electromagnetic problems, and porous media flow. And the other item of his research I'd like to pick out is error estimation. It's been the holy grail in finite elements for a long time that one needed to measure the error in a finite element solution. And following the work of mathematicians in the 70s, Oleg developed an error estimation technique with his student Zhu, and is known as the Zienkiewicz Zhu, or the Z-squared method. And although it was developed in 1968, it is a technique that is used up to the present time to measure the error in a finite element solution. There's a publication there which actually summarizes his full academic career. Honours and awards. One thing that is interesting, that he had over 30 honorary doctorates, and there's a list of some of the major awards that he received. I'll only pick out the Royal Medal of the Royal Society and the Prince Philip Medal of the Royal Academy of Engineering. One thing I want to point out is it's not an accident that Oleg spent all his career in Swansea, and that is largely due to his love of sailing. And if any new research student or research visitors came to Swansea, they were quickly roped in to act as crew, but any competitive instinct during a race would quickly vanish if a particular finite element topic arose. The last slide on Oleg, it is the later years he spent in Barcelona. He was at the SMEs, Centre of International Methods in Numerical Engineering in Barcelona, that was due to his close interaction with his former PhD student, Eugenio Oñate, and he became the UNESCO professor at SMNI. And the idea for the UNESCO chairs arose from this book, David Lawrence's Small World. And in this book, professors of literature imagine a UNESCO chair that will allow them to retire into a world of continuous travel with no lecturing obligations, and at an extravagant salary. Oleg's UNESCO chair was the first, and it was facilitated by Geoffrey Hollister, who was working at UNESCO, but previously had been on the staff at Civil Engineering in Swansea. And it's interesting to note there are now over 300 such chairs, such UNESCO chairs. The other thing that consumed his time after his retirement was the development of his book, which he spent time with Bob Taylor in Barcelona or in Sitges for this purpose. And during his time in Sitges or Barcelona, Oleg became familiar with the work of a sculptor, Emilio Tristan, and he saw some of his work and he commissioned this particular bust. And this bust actually resides in the engineering department at Swansea University, and it served to remind us all of the remarkable achievements that Oleg has undertaken, and actually showed that he's one of the premier academics of the 20th century. Okay, with this background, Swansea decided it would be appropriate to establish annual lectures to mark the work of Professor Zienkiewicz. And with Oleg's interest in computational modelling and Lord Bhattacharya's outstanding efforts in establishing Warwick Manufacturing Group, there's no hesitation in inviting Lord Bhattacharya to deliver this lecture. To summarise Lord Bhattacharya's life, which is very difficult to do, he was born in 1940 in Dhaka. He graduated from the Indian Institute of Technology, Kharagpur, and then he subsequently entered Birmingham University to study for a master's and doctorate degrees in engineering production. His career in manufacturing actually took off afterwards. In 1980, Lord Bhattacharya was invited by the University of Warwick to establish a manufacturing, teaching and research facility, which is now known as the Warwick Manufacturing Group. He has built WMG into a unique academic institution. It employs over 550 staff, has 8 buildings with more than 28,000 square meters of research, education and impact space, and is based on the University of Warwick. He has also initiated with private sector funding a new 150 million, 33,000 square meter National Automotive Innovation Centre, together with a 11 million degree apprentices academy and a 10 million materials engineering centre. And most recently, WMG has been invited to develop the new UK Battery Industrialisation Centre. This £120 million programme is a key enabler for high volume battery manufacturing and high volume electrical vehicle production. On the educational front, Lord Bhattacharya firstly formed the first industry-focused residential modular education programme known as IGDS, with the intention of providing individuals and companies with engineering and technical expertise. And some 10 years later, he established the first engineering doctorate, which is a research degree coupled with the development of the competencies required of an engineering manager. More recently, he's been responsible for the WMG Academy, which is a distinct business-focused, business-led initiative for students aged 14 to 18 studying engineering with digital technology. The first one opened in Coventry in 2014, and the second WMG Academy opened in Solihull for 1,000 students in 2016. But the most remarkable thing of all is all these educational programs have been sustained for over 35 years, and over 37,000 individuals have gained a University of Warwick qualification, which is indeed a remarkable achievement. Lord Bhattacharya's personal research is focused on machining and process innovation. His patents have been applied to aluminium castings and machined parts, and this led to the creation of a company, Transtech, that at its peak employed more than 4,500 people. At WMG, Lord Bhattacharya built the first national capability in additive layer manufacturing, novel innovations in polymers, for example, in-mold painting, and new approaches to joining multi-materials. He was a pioneer in the introduction of digital technology to manufacturing, with CAD/CAM, product life cycle management, simulation and modelling, robotics, and embedded systems featuring prominently in the research agenda over the last 25 years. Well, naturally, Lord Bhattacharya has been the recipient of too many honours to list in full, but some principal awards include: nationally, he was knighted for services to higher education and industry in the Queen's Birthday Honours in 2003, and was raised to the peerage in 2004. He's a fellow of the Royal Society, the Royal Academy of Engineering, the Indian National Academy of Engineering, and the Institution of Mechanical Engineering, amongst others. He was presented with the City of Coventry Award of Merit in 2014 and created an honorary Freeman of the City of Coventry in 2015. In 2010, Lord Bhattacharya was presented by Her Majesty the Queen with the Queen's Anniversary Award for Higher and Further Education in recognition of the IGDS scheme. And finally, in 2016, he was conferred with the Regius Professorship by Her Majesty the Queen, the first such award in manufacturing. Internationally, he has worked in close partnership with India throughout his career. In January 2002, he was honoured with one of India's highest honours, the Padma Bhushan, by the President of India for services to science, technology and industry. In 2008, he was awarded an honorary doctorate by his alma mater, the Indian Institute of Technology, Kharagpur, and he's additionally been awarded honorary doctorates by universities in Australia, China, Malaysia and the UK. In China, Lord Bhattacharya was awarded the inaugural National Rainbow Bridge Award in 2015, and in 2017 he received the Great Wall Friendship Award. And finally, in 2017 he received the Chinese Government Friendship Award, the highest award of the Chinese government to honour foreign experts, which was presented by the Vice Premier Ma Kai at a ceremony in the Great Hall of the People. Well, with this distinguished background, I'd now like to hand the floor to Lord Bhattacharya to deliver this year's Zienkiewicz lecture. Lord Bhattacharya.
Thank you for your kind invitation to the second annual, let me get my pronunciation right, Zienkiewicz lecture here at the National Waterfront Museum. My secretary is Polish, so she explained to me how to sort of pronounce. And my special thanks for the introduction, and my also thanks to Swansea University and your staff for the wonderful hospitality that you've shown me. It's a particular honor to give this lecture because all engineers, like myself, who have designed products, owe Professor Zienkiewicz an enormous debt. His work developing the finite element method into an essential research and modeling tool has had a truly global impact. There are many people who do a lot of things, but very few people have global impact, especially academics. You will know that he first used the technique for the stress analysis of your dam in 1963. But today it is used across the world on everything from nanostructures to space exploration. Of course, the extent of the impact of his work lies not just in the papers, products, and infrastructure that rely on his work, but on his careers he has launched and the Zienkiewicz Center himself. This center for computational engineering is a fantastic initiative, one that builds on the computational engineering expertise of Swansea University for over 3 decades. I'm particularly impressed by the range of your research, the research on medical devices, led by Professor Netha Su, to the success of your work in aerospace engineering and dynamic modeling. It's also a great pleasure to be back in South Wales. With the future of the Port Talbot Steelworks secured, I remember for about 5 years I was involved in, at that time, with Cyrus Mystery and having many discussions with the union, government, and Tata Steel as we worked very hard to sustainable future. And it's very good to see so many of my friends from Tata Steel, Swansea, and WMG amongst the audience this evening. If you know what went on behind the scenes in order to secure Tata Steel, I can tell you this, one could write 2 books, because it's a combination of politics, international economics, and the whole purpose that the British government wanted a steel plant but did not want to support it directly. And when then Chandra came in as the great friend of mine, a childhood friend of mine, great engineer, wanted to keep Port Talbot going, not because it's a steel company or any such thing. They realized that it's the DNA of Wales. And I also think that today in the field of automotive engineering, I think of William Robert Grove, who invented the Grove cell in 1839. The Grove cell provided a high current and nearly twice the voltage of the Daniel cell, which made it the favored cell of the American telegraph networks at that time. While for many years battery engineering was something of a backwater, especially in automotive engineering, is now absolutely fundamental to innovation in this sector. We have much to learn from studying the pioneers of battery research. I also want to mention William Preece, the great telegraph and wireless electrical engineer. It was with the support of Preece that South Wales became home to one of the great moments in the history of communication. It was a great moment in history when at Larnock Point in 1897, Marconi and Cardiff George Kemp succeeded in transmitting Morse code over the open sea for the first time. Conscious of these great innovators of South Wales, in my lecture, I want to heed the wisdom of Preece in his inaugural speech as president of the Institution of Electrical Engineers. True theory does not require the abstruse language of mathematics to make it clear and to render it acceptable. All that is solid and substantial in science and can usefully be applied in practice have been made clear by relegating mathematical symbols to the proper storage place, the study. Considering the subject of my lecture, harnessing automotive innovation, I think it's worth adding one more tribute to Professor Zienkiewicz. As a young engineer, Oleg approached the consultancy firm of Sir William Halcrow and was offered a post leading a survey on a dam project in Scotland. After being offered the job, Halcrow asked Oleg if he could drive. Naturally, Oleg said, and went off to get a provisional license. He never passed the test for a regular driving license. I hope one day we will develop the automotive industry to the point where future Zienkiewicz will be safe and secure on the roads, full license or no. Oleg's lack of driving license reminds us that when considering how to pursue innovation, we should consider where we currently are. It's a changing world. Today's world is changing at a pace we have never seen before, becoming even more volatile, uncertain, complex, and ambiguous. We are experiencing an era of disruption to traditional business models. Companies like Amazon, Airbnb, Uber, or Alibaba that started as disruptors are household names today. The iPhone launched just over a decade ago. Now there are around 2.5 billion smartphones worldwide. So the fourth industrial revolution is upon us. Autonomous, connected, electrified, and shared vehicles are becoming real, enabled by the Internet of Things and big data. The fourth industrial revolution is upon us. Autonomous, connected, electrified, and shared vehicles are becoming real, not just talk, enabled by the Internet of Things. New designs, new propulsion systems requiring new technology solutions across many, many sectors. That means the automotive industry is poised for more change in the next 5 years than in the last 50. There will be no big bang or one-off announcements. This transformation is a journey. The nature of that journey will be defined by two elements. First, demands for change, both from consumers and society, and second, by our ambition in meeting those demands. The current state of mobility, a number of global trends are influencing the shape and pace of this disruption. Let me highlight the most relevant to us. The first issue we need to consider is what is powering the growth of the global automotive sector, both in terms of types of vehicle produced and national demand. Last year, the automotive industry produced some 97 million cars and commercial vehicles worldwide, with the big three, the EU, USA, and China, accounting for around 2/3 of the global sales. In just the last decade, the number of cars and commercial vehicles sold in China each year has tripled, from less than 10 million to almost 30 million. On the manufacturing side, China is, of course, now responsible for over 1/3 of global automotive production. To put this in perspective, China now produces as many cars as the European Union and the USA combined. However, this is only part of the story. My very good friend, who owns Geely, Li Shufu, used to spend 20 years ago or 25 years ago making money after taking photographs of Westerners on the streets of China. That's how he made a living. Now, he is the world's largest car manufacturer. Now in Europe too, he's taken 10% of Daimler. He owns Volvo. He owns the London Taxi. He owns Lotus. Now there are many, many other things which I cannot mention because of commercial interest. Inside growing nations, we are seeing huge shifts in global populations. In 1800, just 3% of the world population lived in cities. For 2018, that figure has passed 50%, and by 2050 is expected to exceed 70%. The rapid urbanization places increasing strain on cities in infrastructure, resources, and space. It also hastens the need for smarter, safer, more integrated mobility solutions for inhabitants. Often neglected in in Western consideration of the future of the automotive sector is the motorcycle and scooter market. Yet in India, we see an incredible two-wheeler market with motorcycles and scooters making up over 80% of total automotive sales. Scooters are a particularly fast-growing sector in the Indian automotive market. Indeed, scales of scooters give firms like TVS almost 20% growth year on year. Indeed, over the last 5 years, two-wheeler sales in India have grown roughly a third. And we are at Warwick, at WMG, designing the next generation of two-wheeler market. That means India has surpassed China to claim the title of the world's largest two-wheeler market with 70 million sales each year. These consumers will demand safer, lower emissions, and will do so in their tens of millions. As all this creates huge untapped demand for mobility. Current projections are that in China, personal mileage traveled by car will increase by 183% in the next decade. We will also see modes of transport change. Nor is the Western market saturated. AutoFacts assumes that personal mileage in Europe could rise to 5.88 trillion kilometers by 2030, an increase of a quarter. A similar increase is projected in the United States. With increased demand for travel comes increased demand for less congestion and better infrastructure. Congestion in the UK alone is estimated to cost each driver over £1,000 per year. When we consider the increased urbanization of the global population, it is clear that we need to both reduce the pressure on road networks and build a road and vehicle infrastructure that efficiently supports mass transportation. If nothing changes, rising consumer demand for mobility will mean an even greater dominance of the petrol and diesel engine. Currently, car usage takes up a staggering 20% of the global daily demand for oil. 20% of the global daily demand for oil. Over 20 million barrels every day. Adding in freight lorries, aircraft means vehicle transport accounts for almost 30% of global energy use and 45% of global oil demand. Without innovation, this would undoubtedly become completely unsustainable very rapidly. This points to the many imperatives behind automotive innovation. The need for vehicles to support a sustainable environment, both locally and globally. Vehicles currently produce 12% of the EU emissions of carbon dioxide. Accordingly, legislation has been enacted within the EU and around the world to drive a reduction. Indeed, it's entirely possible that within 2 decades, the petrol and diesel engines will be banned from the roads of many developed countries. The same may be true of the fastest growing automotive markets. The internal combustion engine is responsible for around 30% of the air pollution in China. If you are living in one of the Chinese megacities or governing one, the impact on the quality of life of pollution is significant. Already many Chinese cities have placed limits on the number of the new registrations of internal combustion engine licenses. The impact of this on the global electric vehicle market is astonishing. Last year, China sold around 500,000 electric vehicles, already almost half of the global total. This year is on target to more than double that, selling 1 million plug-in battery cars. In other words, the Chinese market this year is the same size as the global market was last year. This shows us how quickly regulation and legal networks might affect the shape of the global industry. The next key factor we should consider is safety. Despite the tremendous strides being made in automotive safety, the World Bank estimates that 1.25 million deaths occur in road traffic accidents each year. At least 20 million people are injured in the same way. The mortality rate is far higher in less developed countries where 50% of global vehicles produce 90% of the deaths. In the last 25 years, average road traffic mortality in all OECD countries declined from 22 to 8 per 100,000. In China and India, however, despite much lower vehicle usage, deaths are still above 20 per 100,000. In some ways, this is encouraging. As it suggests, we already have the global tools available to reduce death rates substantially. However, there's clearly a great deal to reduce the toll of transport, and it must be a priority as demand for personal transport can only increase further. Also, we must remember that cyclists and motorcyclists have the most significant risk of injury, which makes designing in safety essential in rapidly expanding urban transport sectors such as electric vehicles and scooters. So these are the challenges. What about the solutions? You might be feeling a little bit depressed at this point. I encourage you not to be. For all the challenges and issues I raised above, it's important to remember the positives. First, vehicle transport has had a tremendous liberating impact on individual lives. We can now travel further, faster, and in greater comfort than even before in human history. Further, those advantages are being rapidly shared with individuals, with hundreds of millions of our fellow citizens, enabling them to live with more freedom, choice, and opportunity. Next, we have shown, for example, on road safety, that effective solutions already exist to some of our most pressing problems. The challenge is to make them universal. How do I know this? Because the work for a better transport future has already started. At WMG, we are creating the next generation of vehicles driven by new propulsion methods. Electrified, zero-emission technologies powered by integrated smart charging networks. We already see the opportunity. Our response is what we call Destination Zero. Zero-emission vehicles, zero congestions, and zero accidents. Intelligent, networked transport solution for a smarter, cleaner, safer society and a more productive economy. Let's look at some of the solutions that are being developed today. Stricter emission regulations and pressures on global energy demand has produced massive growth in research on fully electric and hybrid vehicles. Lower battery costs, widely available high-speed charging stations, and increasing consumer acceptance will create robust momentum for electric vehicles, whether hybrid, plug-in, battery electric, or fuel cell in the coming years. Britain has identified battery technology as one of the great 4 grand challenges for the UK industrial strategy, with the creation of the Faraday Battery Challenge. The scale of the challenge is significant. To get to a zero tailpipe emission position within 2 decades, we need to double the energy density of batteries, quadruple the power density, double the life of the battery, and make it wholly recyclable and cut the cost by 1/3. This requires significant investment in battery technology on all fronts. So at WMG, we are just doing that. One element of our research is to replace graphite in the anodes of lithium-ion batteries using silicon. Graphite has been the choice of active material for anodes in lithium-ion batteries since their original launch. But researchers and manufacturers have long sought a way to replace graphite with silicon, as it is an abundantly available element with 10 times the gravimetric energy density of graphite. We have found ways to do this by reinforcing the anode's structure with graphene girders. This would more than double the life of rechargeable lithium-ion batteries by substantially extending the operating lifetime of the electrode and also the capacity developed by these batteries. Solid-state lithium-ion, looking further ahead, one area showing great promise is the development of solid-state lithium-ion batteries. Several approaches are being followed to make this functional, include sulfide superionic conductors, developing a liquid to solid nanocomposites, electrolytes, or physically stabilizing the lithium metal surface with a ceramic. It's too early to tell which of these approaches will produce the greatest benefit and rechargeability. But what is clear is that research around the world is advancing very, very rapidly. British manufacturers will need to build partnership with knowledge networks with researchers from China, Korea, and the US to make sure we are able to make the most of their innovation advances. This isn't as far as some imagine. Just last week, the Chinese startup company Qingtao claimed to have entered production of solid-state batteries, following a $140 million investment. In the US, Volkswagen has invested $100 million in Quantum Scope at Stanford, which is over 200 patents on solid-state batteries. Naturally, moving from one power source to another does not reduce the demand for energy by a vehicle. This is controlled by the efficiency of the propulsion system and the burdens the vehicle must carry. Today, vehicle bodies contribute 25% of the total weight of a car. A lighter body car can use a lighter engine, a lighter suspension, creating a circular weight saving, doubling the original benefits. This has the further benefit in electric vehicles of extending the range of these vehicles. Our research focuses on addressing the manufacturing challenges preventing the mass application of advanced lightweight methods. For example, resistant spot welding had traditionally been ignored as it was impossible to control in lightweight materials. There was no guarantee that these joints will be reliable. However, the theoretical analysis showed that the contact resistance was the vital issue of joint integrity. It was influenced by a range of factors, including the surface conditions of sheets. This allowed pioneering approaches to the joining of high-strength steel and aluminium. These have helped develop lighter cars, e.g. as the F-Type and the 420 kilograms lighter Range Rover. And then our technology was used by Audi, by BMW, everywhere. Often, progress is very granular. Our composite, lightweight automotive suspension system, class for short, has produced a 4.5 kilogram in weight reduction in just a single component of a Ford's rear suspension by replacing the car's current multiple-piece fabricated steel tie, blade, knuckle with a single molding. These steps show how much can be gained with existing materials. However, I'm delighted to say that just this month we were able to take another step forward on lightweighting vehicles with the announcement of Project Tucana to introduce new materials into the supply chain. This £37 million initiative is designed to develop a world-leading, cost-effective, scalable carbon fiber composite car body structure with a particular emphasis on using weight reduction to boost the performance of electric vehicles. This is a major advance in making electric vehicles more capable, expanding their usability and potential market share. Increasing research in composites and will enable further lightweighting through embedded functionality. This would enable, for example, the removal of the wiring harness in cars and the copper lighting strike shell in aircraft. Research being explored in collaboration with industry partners and others, including functional nanomaterials, carbon nanotubes, graphene, 1D and 2D inorganics. At WMG, we are working to incorporate these into bulk and formed polymer and low melting point aluminum systems. We'll subsequently process them to produce lightweight multifunctional components. The aim is to produce components that are simultaneously stronger, smarter, and lighter than anything that has gone before. Speaking of material usage, a significant challenge is that of the life cycle analysis. It's no longer sufficient to consider the CO2 saved during the use of a vehicle. One should now has to consider the CO2 associated with materials development, vehicle manufacture, and end of life. The energy cost and CO2 output per ton of steel have, during the last 2 decades, been reduced by nearly 30%, but we can go much further. The Royal Society People and the Planet 55 report encourage the investment in sustainable resources, technologies, and infrastructure, and systematically decoupling economic activity from environmental impact. If we want to get more efficient and environmentally friendly alloys to market rapidly, we need to develop new ways of testing and researching the properties. The vision has led to the exciting new EPSRC, Tata Steel Prosperity Partnership flagship investment in long-term use-inspired fundamental research, this university and WMG to come together to create a new virtual factory of rapid alloy prototypes. The impact of this approach in our partners, including our friends in Tata Steel, is enormous. We'll accelerate the translation of innovative steel chemistry and process improvement to the steel industry. We're able to seize opportunities to increase steel scrap levels in new steel production, contributing to the circular economy in the UK. New steels are needed for more efficient cars, fuel-efficient cars. This will allow users of steel to drive innovation that meets market needs at a lower cost. After all, just testing a single new alloy can require up to 900 tons material, where a virtual factory can produce this in just a few grams. We can see how improving the power source vehicles use, reducing the weight and increasing the strength of vehicles through new materials and computer modeling can improve the energy efficiency, life cycle, and range of a lower vehicle cost, energy impact, and improving safety. In 2005, I spoke of the holy grail of systems integration and the emergence of the world platform of connectivity that previous generations of engineers could only dream about. This has come rapidly to fruition, with virtual testing enabling designers to anticipate how a system will perform, simulate how it will interact with users, and discover when it might fail, all without leaving the laboratory. Today, cars on the road are being equipped with danger warning applications, traffic information services, and a host of infotainment features and increasingly active safety features. The number of networked cars will rise 30% a year for the next several years by next year. By next year, almost 1 in 5 cars will be connected to the internet. However, this connectivity is still primarily user-led. Drivers seeking information about better routes and how to avoid speed traps, or passengers using their car as a media device. We are clearly still in the infancy of connected vehicles. In future, we will see considerable changes to vehicle connectivity and intelligence. Up to 15% of the now cars sold in 2030 will be fully autonomous. Autonomous, in particular, shared autonomous vehicle could be far better utilized than is the case with traditional vehicles today. We are currently in a single-owner, multi-purpose world. You buy or lease a vehicle and use it for all your travel needs. This is an incredibly inefficient use of vehicles. You don't really need such vehicles. The vehicles that are capable of self-driving, then developing vehicles where they are needed on demand, is the future. PwC forecasts that by 2030, more than 1 in 3 kilometers driven could already be sharing concepts. And Europe and in the US, these changes are expected to roughly parallel pace. At China, this is moving at such a rate that one cannot believe it. Now, advanced driver assistance is something that we can do very quickly. And these are now being tested, and the British government is putting huge sums of money in infrastructure and trying to simulate what it is going to be like if this came into fruition. So therefore, virtual testing of smart vehicles, all media reports have shown developing safe, fully autonomous vehicles is an iterative process. So therefore, we at WMG, working with a consortium of 11 organizations to create a highly accurate virtual reality simulator environment, including artificial intelligence, train models of pedestrians and road users to test connected and autonomous vehicles. The project will validate the realism of the simulator. Looking further forward, smart vehicles will learn driver behavior, increasing vehicle safety. They'll optimize to the driver to reduce emissions and fuel consumption. At WMG, we have had a recent breakthrough on a new communication system for smart vehicles. Data transfer rates at this level will allow autonomous vehicles to share large quantities of data with each other and other traffic vehicle systems. So, digital connectivity, the whole end state of self-healing vehicle that can diagnose faults, attempt repairs, and communicate faults to garages will before any mechanical or battery failure. This is what happens in aerospace anyway. So therefore, cybersecurity then becomes very crucial. We have tied up with the biggest hospital in the West Midlands to share data on the whole business of a driver's health and behavior pattern while he's driving an autonomous vehicle. And unless you do that, you can fall asleep, you can have a crash, and you won't understand it. So it's very important that the whole business of mental acuity with drivers, especially in autonomous vehicles, is absolutely crucial. So in conclusion, I believe we stand on the edge of transportation golden age. Surveying the advances we have already made all over the world, I see the possibility of a world of connected vehicles, regulated on emissions, and energy smart provided to users in a very suitable fashion for each journey. Hundreds of millions of people will become mobile in a generation. We will be able to move more rapidly using less energy and with less pollution than we have ever imagined. To achieve this, we need to be restless, demanding and radical. To quote the father of evolution, Charles Darwin, it is not the strongest of the species that survive, nor is the more intelligent, but the one most responsive to change. Thank you very much.
Thank you very much, Professor Bhattacharya. I think covering almost the entire past, future, and present of automotive industry. I think Professor Bhattacharya would like to take maybe 2 questions in the interest of time. So if you have a question. Didn't hear the question.
I did. Any other question?
Any other questions?
I'll come to you in a second.
I'd like to ask how much does your vision depend on the collaboration and cooperation between different automotive suppliers?
Second, any more? Right. Let me answer the first question. You see, autonomous vehicles are a goal. Three things are happening in this world: big data and highly responsible systems. The speed at which this is happening, that unless you can utilize that for your purpose, you will never progress. Number two, I'm not suggesting there'll be autonomous vehicles tomorrow. The technology is still there. If you want to drive an autonomous vehicle, the technology is still there. It'll depend on the infrastructure that is there, and it depends on the commercial initiatives that are there. But what is clear, of course, the whole business of big data, communication, 5G, and at the same time, the pressure on the environment and the pressure and the commercial pressure on competition. The pathway has to be done in such a way that you can implement it as you go along. That doesn't mean tomorrow you will have completely autonomous vehicles on the road. Right, what is the other one?
Suppliers working together, automotive suppliers.
Automotive suppliers.
And working together.
Well, they are already there anyway, because they realize, not just suppliers in UK, they realize worldwide. Do you know the suppliers, the major suppliers that were there or that are there now, I suspect 40 to 50% of them will disappear, because the technology that the car is using, the materials the car is using, the materials of the drive systems that are there are totally different. Now, companies like Google, where you and various other companies are actually moving in so fast, not just for autonomous vehicles, even for current vehicles.
Can I ask you something?
Yeah.
Oh, sorry.
The name is privacy. So there is development that is taking place in the battery space for the cars, but storage
There's a lot of work that's taking place in this particular area. The problem is the variability and the cost of storage in different parts of the world. And for example, if you want to store energy in such a way that you can recharge your batteries very quickly, you can do it by normal grid, by solar, wind, and all that. But the variability of that around the world is such that you can't concentrate on any particular one, because the cost itself will be phenomenal. But there is enormous amount of work that's being done in this area.
Can I ask, you talked a lot about two-wheelers. Will they ever become autonomous?
Well, it's a journey. I mean, I reckon the small transport systems like in India, like the auto rickshaw,
Yes.
that will disappear in 5 to 10 years, because I've seen cars, small cars being made, which can replace that, partly because of emission, and secondly, partly because of the cost. And today I know the government of India is actually encouraging companies, and they are subsidizing companies on doing testing on new types of three-wheelers. There will be three-wheelers will disappear, they'll all be four-wheelers, and there will be small pods where they can take it in the city, leave it there for half an hour, and then it'll get charged. But that's a wish.
Thank you, and it's very nice talk. I'm Zienkiewicz from the College of London. For automotive industries, and now the three major manufacturing technologies, such like machining, casting with a traditional manufacturing technology, and forming are widely used nowadays. How do you think in 50 years' time, and when those technologies will be the major manufacturing technology for car manufacturing, or change it to 3D printing or something else?
If you just look at machining itself, it's already 40% lower than 25 years ago, because there's much more accurate forming, there are different types of materials, there are different types of joining techniques, which will be one-stop shop, they call it. I don't believe that work, I mean, I did my PhD on machining, and I think it's quite embarrassing when I say to people, I did my PhD on machining. They will say, machining? That's disappeared. I mean, if you look at cars today, how much of it is machined?
And so, just to understand your view on the ethical dilemma and issue of autonomous vehicles, is that being solved, the famous problem of passenger or in an accident situation, whom to save and what is the implications of that? Have the governments have come up with regulations, or is it moving on in terms of what is the future of that? This ethical dilemma of an accident situation in an autonomous vehicle, if there's a passenger inside and somebody who's driving the car and somebody's in the street in an accident situation, how to control that?
Okay. You see, that's the reason that the amount of work that is being done in this area is huge. There will be quantum pods. People will not be able to, and the driver or whatever it is, will immediately get very quickly, because of the speed of this information, to either stop, and there are many simulations of that, different types of simulations, in order to be able to handle that. It's still in the early stages. There are very few streets with pods, and if you look at what happened in America when people got killed driving with autonomous vehicles, the whole speed of integration has slowed down till the factor of safety is such that is acceptable to the government and to ordinary public.
I think that probably has to be the last one.
Climate science says we need to be at global zero emissions by 2050. Now, I've seen very few people have a solution for transport, and I think what you set out tonight is a solution for zero carbon for transport. It's autonomous battery. I can see that working. Is the technology such that we can, through market forces, make that happen by 2050, or do governments need to intervene through some sort of legislation to drive this agenda? How much is it market and how much is it policy?
Technology is there, so that's not a problem. You know, if you look at governments all over the world, they do a lot of talk, but when it comes to legislation, they slow it down, mainly because the cost of implementing is so high, and secondly, there's so much employment in the current method of doing business. So the speed at which, whereas in England, of course, under the industrial strategy, they have spent a lot of money, are spending a lot of money, but it's minuscule compared to what is required. And hence more governments are working to that. For example, today, in Brussels, all the European countries are meeting to make sure that the momentum in this area can be maintained. Saying that momentum should be maintained and actually doing it is two different things.
Thank you very much, Professor Lal Bhattacharya. So now I invite Professor Roger Owen to present the Zienkiewicz medal.
He wants to come down.
He wants to come as well. Come on, let's all together.
Okay.
First of all, before I present the medal, I'd like to thank you for the lecture. It's very thought-provoking. And as well as presenting the difficulties ahead, I think you've also pointed out the possible routes to solution. And you can tell that from the questions that were asked on the floor tonight. So thank you for the lecture. First of all, my task is to present you with this.
Few more minutes, maybe a drink. Now I invite Dr. Professor Dave Worsley to give the vote of thanks. You can sit down now.
Right, thanks very much. Thank you to all the speakers. Certainly inspiring to hear from both Arasu and Roger about the work of Professor Zienkiewicz over the years and the degree to which that's influenced the whole of manufacturing. Particularly, though, I'd like to thank Lord Bhattacharya for coming here today and speaking to us. I think from the point of view of the steel industry, firstly a vote of thanks for the work that you engaged in with colleagues, other colleagues in the room, including Bim Blender and other, to secure Port Talbot and the associated Tata Steel plants in Wales. They're really, really important. So, thank you very much for that incredible effort that you've done there to support our industrial base. And worthy of mention is we are obviously now formally collaborating through EPSRC funding on this kind of mini factory idea on alloy development and in other areas. And again, I think this is an exciting time where Swansea and WMG join together to deliver more for the manufacturing and metals sector. Very exciting to see all those steel-clad buildings going up at WMG as well. So Tata Colours now in the room. Yeah, get you guys over to Warwick so you can get the orders sorted. And very exciting to see both the historical and current activity in and around people development and training. Absolutely core as well to Swansea's DNA. Again, like WMG, one of the first NGD centres and the NGDs and that kind of tiered training that goes all the way down to sort of training people in the factory how to operate stuff. Again, we can do some really great stuff together, I think, with Warwick to deliver the future supply chain of talent that will power our economy forward. Really exciting to see the work on batteries. It's an extremely important area, particularly for transport, but again, I think as Bimlendra pointed out, for buildings as well, and the way in which the cars and the buildings talk to each other and how they can share power, I think is going to be really exciting as we move into the future. This is a bit of audience participation here, which might not work, right? So at the moment, I'm going to ask an awkward question. Who has an electric vehicle in the room? Oh my goodness, right? So I'm going to put my hand up. Yeah, right. So there's a few electric vehicles in the room, but what I'm really excited about is that the work that's going on at Warwick and driving automotive electrification will mean that in 5 or 10 years' time, I'm hoping at least half or 3/4 of you will put your hands up, even Professor Steve Brown in the back there with his Land Rover. I must say I'm not 100% all electric, of course, because I've got a V8 Land Rover Discovery too, which probably offsets my carbon savings just on one trip out. So, I'm not lily white in this, but a final thanks then to you all for listening. But at the end, if we could finally thank Professor Lord Bhattacharya for his excellent talk in the normal way. So thank you very much indeed. Okay, we're doing some more presentations now, so here we go.
Sorry, unfortunately, Professor Lord Bhattacharya is not going to stay for dinner, so we have more presents for Lord Bhattacharya takeaway. So I invite Professor Worsley to now present the hamper and a bottle of Welsh whiskey.